This video is a stepping stone to being able to calculate with measured values, but what we're going to focus on here is how to count how many measured values there are within a measurement. Okay, so the chemistry or the scientific term for measured values is actually called significant figures. Significant figures is just another way of saying measured digits. So if the digit you wrote down was measured, it would be a significant figure. Okay, so all of your digits or numbers, even the zeros that come from a measurement tool, are considered significant and measured, even that one last estimate. Okay, and by knowing how many measured values you have, this will help you know how to round numbers when you calculate with measured values. Okay, so in science, again, we're not willy-nilly with our measurements, since every single, the precision of our instrument really tells us how much money was put into that measurement, and we can't discount that when we're dealing with real world things. Okay, so here are kind of the simplified rules for how to know when I'm looking at something if it's considered a measured digit or not. So step one, if it is a digit, right, a non-zero number, it's considered measured because no one could come up with a 5 without measuring it. And again, even if it's their estimate, it's still considered a measured value. So really, when it comes to deciding if something's measured or not, it's the zeros that are obnoxious. Because when we see a zero written down, we go, well, I don't know, was that zero received from a measurement tool, or was it written down essentially as a placeholder? So placeholder zeros are not significant. So here are some not really scientific rules, but kind of easy ways to figure out if a zero was measured or not. So if you see a number with a decimal point, whether it's a number greater than 1 or less than 1, start all the way on the left of it. Okay, so on the left, go to your first non-zero, and if that's a number greater than 1, it'll be for the first digit. If it's a number less than 1, you'd go to the first non-zero, and then that first digit, as well as everything else to the right of it, is considered measured, including the zeros. And I'll apply these rules here in a second so you can see. If you don't see a decimal point, then instead of starting on the left, start on the right. Okay, so start kind of that location where a decimal point would be if your number had one. And then from the right, move to the left and find your first non-zero. And that digit, as well as everything else to the left of it, would be considered measured. Right? So that's essentially what I do when I'm trying to figure out, is it measured or isn't it measured? Now, what's super nice is if you see a number in scientific notation, everything written before the times 10 to the whatever is measured. So any zeros written there would be considered part of the measured value. Okay. A couple other things, just pointers in relation to measured values. In order to care about significant figures, it has to be a measured value. Okay? So without a label, it's not a measured value. We don't sig fig non-labeled numbers. Okay? Non-data means it's just a number. It doesn't mean anything. And so that also means if you're doing a number that's not a measurement technically, we don't sig fig it. So if you're just counting something, like there are 10 pencils, we wouldn't sig fig that because there's no doubt about any uncertainty in terms of the accuracy of your measurement because you counted them, okay? Also equalities. So if you have 1 foot is 12 inches, that equality is not technically a measurement. It's like a 1 equaling a 1. So we don't round those at all. And then constants. So the speed of light is 3.0 times 10 to the 8. We don't round our numbers based on the precision of a constant, because usually a constant is well known to infinity. Okay, it's not a measured value technically. So let's apply these rules to a whole slew of measurements. Okay, so number 1 up here, when I look at it, I see that it is a number that does not have a decimal point. So I'm going to start over here where the decimal point should be and move over to my first non-zero, which is the 1. And so then the 1 and everything else to the left of it would be considered measured. So that has 2 sig figs or 2 measured values. Number 2, I have a decimal point, so I'm going to start over on the left instead of the right, find my first non-zero, which is the 5, And so the 5 and everything else after it is considered measured then. So there are 4 things there, including that 0. For number 3, I see that it does have a decimal point. So start over here on the left, which means both of those count. 4, though, doesn't have a decimal point. So if I start over on the right and move to the left, only the 2 was measured. So that 0 is what we usually call like a placeholder, meaning without it, right, 2 is not 20. That 0 is there to get us to our right value of 10. Am I talking about 2 or 20 or 200? But it's not measured. It's just a placeholder. Okay. So 5, I have a decimal point. So I start over on the left and I move to my first non-zero, which is the 1. And then the 1 and everything after that is considered measured. So that's 4. Again, these first zeros then would be considered placeholders. Without them, I'm saying I don't have 1,000th of something. I'd have like, a 1/10 of something. And those are very different in terms of measurements. 6, decimal point. So I go to my first non-zero starting from the left. So the 4 and everything after that counts. So there's 6 of them there. For 7, I see a decimal point. So I start on the left. That first 9 is measured. So then everything after it is measured as well. So there's 5 of them there then that are measured. 8, decimal point, go to my first non-zero, which is the 2. So the 2 and everything after it is measured. So there's 5. And then the 9, beautiful scientific notation. None of those zeros are measured, but everything written in front of scientific notation is considered measured and significant. So there's a little intro preview of how to measure or how to count measured values in sig figs. Go ahead and try the practice on your own and have a nice night.